Share the screen. And here we are. Okay, I think we're in business. Okay, so there's really just one more section before the test next Thursday, and I already started some of that. So I'll do more of Chapter 5 test today, and then after a certain time, I'll stop, and we'll do our next quiz. And then Tuesday, I'm guessing Tuesday I'll probably be able to finish early. Okay, so look at what's going on here. So we're here. I've already done some of the Chapter 5 tests, so I'm a little bit ahead. So Tuesday, I probably won't need the entire period, so let's plan on this. For Tuesday, as soon as I'm done lecturing on Chapter 5, if you want to bring up questions on any of these sections, you may do that in preparation for the test. Okay, so think over the weekend. Well, I'll do some more of Chapter 5, but since I'm already done with Chapter 0, 1, and 2, if you say to yourself, you know, I want to go back and do this problem or that problem, okay, have that prepared ahead of time, because I don't think I'm going to need to lecture the entire time on Tuesday. Then I'll let you have a question and answer period before the test next Thursday. Okay, so ground rules for the test. I will start off the day by letting you ask questions up to a limit of, let's say, 6 o'clock. So, you know, I'm only promising you 50 minutes, but if you finish early or if you have no questions or we get all the questions out of the way on Tuesday, then we can just start the test, okay? So for the test, you can have one sheet of paper, one 8.5 by 11 sheet. We said, you know, just like this, front and back, okay? And you can have a calculator. So calculator is fine, but you can't talk to each other, obviously. And you have your camera on so I can see, you know, what you're doing. And then when you're all done at 6:55 or earlier, I'll end the class, but then you just take a picture on your cell phone of all the pages of your homework. You need to submit the homework also, and then also of your test. Remember, I have a 70% rule. You must turn in at least 70% of this, but frankly, that's not that hard. I mean, how much do we do in class already, right? Sometimes I end up doing, what, 30%, 40%, 50%, maybe more than half of the problems, in which case you just have to go back and do the rest of the problems. Is that right? Okay, so that's what's going to happen. So I'll do a bunch of problems from here, and I'll do some more next time. And when I think I've done enough, I'll stop and give you the quiz for today. Okay. All right, so here we go. So problem number 3, we're getting back to logarithms. Okay, now theoretically you have seen logarithms before, so I am not going to lecture as if you've never seen logarithms. Okay, you should have seen it in intermediate algebra class, which is a prerequisite for our class. So I'm speaking just sort of in a reminder mode, not in introduction. So number 3 says y equals log base 5 of x. Y equals log base 5 of x. You say, what does that mean? Okay, so we have to write this in an equivalent exponential fashion, and here's the way you do it. Okay, every time you have a log, which stands for logarithm, there's a base next to the g. In this case, it's 5. So you take the 5, you go across the equal sign for the exponent. So I drew arrows here, 5 raised to the y power, and then you come back in for the result. So it looks like this, 5 to the y equals x, or x equals 5 to the y. Okay, so one more time, when you have a logarithm equation, you set it up like this. Okay, take the base, 5, go across the equal sign for the exponent, come back in for the result. So 5 to the y equals x. Okay, now that being the case, if you notice the equation that I have right now, it is easier to plug in for y and then come up with the corresponding x. That's better than plugging in for x and trying to figure out the y. So in this case, I chose y going from -2 to 2. So notice in my table over here, I had y going from -2 to 2, which is exactly the opposite of what I did at the end of last class. right? I had x going from -2 to 2 because that's convenient here. But here, x and y are kind of reversed. So I let y go from -2 to 2, and then I figure out the x value. Okay, so I have this. I'll cover it up, and then I'll ask you again. You don't have to unmute yourselves, but just think, if I plug in 0 for y, I have 5 to the 0. Do you remember what's 5 to the 0? Or in fact, anything to the 0? Anything to the 0 is 1. So I get 1. Okay. Then I plug in y equals 1. If you put a 1 here, that means x is 5. If you put a 2 here, I get 5 squared, which is 25. So right now I have 1, 0, 5, 1, 25, 2. And coming back over here, -1. 5 to the -1. You might recall that's 1 over 5 to the 1, or 1/5. So I have 1/5. 5 to the -2, that's like 1 over 5 squared, or 1 over 25. So this is the chart for this one. 1 over 25, 1/5, 1, 5, 25, -2, -1, 0, 1, and 2. And in case you're wondering, yes, it is true. These are the exact reverse of these. The last one I did on Tuesday. If you just reverse them, you get exactly this, which is interesting. Okay, so I plotted the points. Again, just like over here, I didn't feel like counting by ones. So x goes all the way up to 25. None of the x values is negative, so I don't dedicate any space to it. And I just have y going from -2 to 2. And by the way, this is okay to change the spacing. Okay, I have a different spacing for x than for y. That's allowed. That's okay. Okay, so I plot 1, 0, 5, 1, 25, 2, 5, 10, 15, 20, 25, 1, 2. Now, 1/5 -1. 1/5 is not very far at all, -1. And 1 over 25, that's almost like nothing. It's almost 0 down to -2. Okay, so the logarithm function curves something like that.
Professor, can I ask a quick question on your writing?
Mm-hmm.
So the first one, 5 to the y power up there equals x.
Yes.
And what's that sign?
Equals 5 to the y. Sorry.
Okay,
It's the same equal sign. I'm just putting the 5 to the y on the right-hand side, so it sort of looks like a function.
Thanks.
Thank you. Sure, that's a fair question. My handwriting's bad sometimes, so there it is. Okay, so that's the graph. So this is y equals log base 5 of x, means the same thing as 5 to the y equals x. Okay. All right, I'm going to go back and do number 2 now. So number 2, y equals 3 to the -x. All right, this time I decided to go from -3 to 3. I mean, you didn't have to. -2 to 2 is good enough. But I wanted to do one more 3 and -3, just so you can see what happens. Okay, if I put a 0, what is 3 to the 0? 3 to the 0 is 1. And now this time I think I'm going to plug in the negatives first. It's actually easier to plug in the negatives first. Can you see why? If I put -1 here, I'm doing -1. And -1 is +1. So I have 3 to the 1, which is 3. Same thing for these. These are going to be a double negative. If I plug in -2 right there, that's -2. That's like +2. So I have 3 squared, which is 9. And if I plug in -3, again, the exponent is -3, which is +3. So 3 to the 3rd. So 3 cubed, 3 times 3 times 3 is 27. All right, and now plug 1, 2, and 3 in. 3 to the -1. That means 1 over 3 to the 1. That's 1/3. So this is a 1/3 there, if you can't see it. 1/3. And if I plug in 2, 3 to the -2 means 1 over 3 to the +2, 1/9. This is 1 over 3. And if I plug in a 3, 3 to the -3rd, that's 1 over 3 to the 3rd, and 3 to the 3rd is 27, so I have 1 over 27. Okay, so for the graph, again, notice the y values, none of them are negative, so I skew my graph that way. The y's go all the way up to 27, so I went 5, 10, 15, 20, 25, 30, and just 1, 2, 3, 1, 2, 3. And notice this time, these numbers are so small, it's practically 0, right? So they're going to be close to 0. So let me do these. So -1, 2, 3, 27. Well, I know this one is 30, so I just plot a little bit lower. So I have a point over there. And -2, 9. 9 is a little bit lower than 10, so I put it, let's say, right there. So tell from my graph I kind of missed, but anyway. -1, 3 is not very high. 0, 1. And then, yeah, these three are really, really low, right? 1, 1/3. And this is still lower, 2, 1/9. 3, 1 over 27. This is so low that it's practically right on the x-axis. All right, so it looks something like this. And this is typical of exponential functions. Exponential functions tend to look something like that. All right, then I'll do 4 for you. Again, notice all these problems are right after homework. So every one I'm doing, that's like one less you have to do. Okay, y equals ln of x. Okay, ln stands for natural log. Or log natural. They put the L first to emphasize that it's a logarithm. So ln stands for natural log. And a quick side note, on your calculator, you should have a button maybe like this, ln, for natural log. And for most calculators, above the ln is e to the x. Maybe you can't see it there, but it's e to the x. So ln and e to the x are almost always paired on any calculator. Okay, so what is ln? ln stands for log base e. E is a funny number. It's about 2.71828. Okay. On the calculator that I happen to have, if I hit e to the first power, and I don't know if you can see that, okay? So I did second function e to the x, and I just raised it to the first power, and get it there, 2.718281828. That's the value of e. Okay. So I play the same trick as before. Okay, y equals log base e of x. So log base e is the same as ln. They mean the same thing. Okay, so I will unscramble it like I did over here. You start with the base, which is e. You go across the equal sign for the exponent, which means e to the y. And you come back in for the result, which is x. So e raised to the y is equal to x. Okay, so this original equation, y equals ln x, means the same thing as e to the y equals x. Okay, now, none of us is an expert on raising e to an exponent except for 0. I know e to the 0, that's 1. But if I plug in 1 or 2, you need a calculator. Okay, so once again, in this case, it's easier to plug in for y's. So I let y go from -3 to 3. Then I just plug in. Okay, I know e to the 0 is 1. Oh, I just did it. I did e to the first power was like 2.7, right? Oops, sorry. If I aim it right, it ends up burning your eyeballs out. Sorry about that. Okay, and if I plug in 2, put a 2 right there, I'm doing e squared. And if I plug in 3, I'm doing e cubed. Okay, so on my calculator, sorry, I'm going to hit e. So again, to get e to something, on most calculators, it's second function. My calculator, it's blue, but it's usually up here. I've seen green, I've seen yellow, I've seen red. It's get the second function. So I hit that, and then ln, and it shows up with e to something. Okay, so I want e squared. Sorry. Okay, so e squared is like 7.38. And let me do e cubed. And yeah, you want to try this out on your own calculator sometime. Okay, don't just take my word for it. Okay, so I'm not sure if you can see it. I have e squared as 7.389. I'm going to call it 7.4, round it off. And e cubed looks like it's 20 something. I'm just going to say 20. E to the first power, e to the second power, e to the third power. So 2.7, 7.4, and 20. Okay, make sure you can try it out on your calculator. So there it is, 2.7, 7.4, and 20. And then I do the negatives. Okay, so I'm going to plug in -1, -2, and -3 with e. Okay, now on my calculator and many calculators, to get a negative, you use this button down here that has a little negative. Don't use this one. This one is for subtraction. So if you have a calculator like mine, a TI 81, 82, 83, 84, any of those, okay, don't use this button for the negative. That's for subtraction. This one here gives you a negative, okay? Other calculators, I've seen a plus or minus button. So a regular scientific calculator, you might have a button that looks like that. That's how you would get a negative. So you would type the number like 2 and then hit that to get a -2, okay? But for me, okay, so I want e to the -1, right? So second function, ln or e. So now my calculator says e, and now I want -1. So negative on my calculator, and I'm guessing a lot of your calculators, is this button. So -1. Okay, so there's e to the -1. 0.367, blah, 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 blah. So I'll just say 0.37-ish, as you can see right there. And then e to the -2 and e to the -3. Okay, so this is what they come out to be. So second function, ln, so that gives me the e. And this time I want the exponent to be -2. So I come down here for the negative and then 2. Okay, so there it is, e to the -2. Hit enter. 0.135, blah, 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 blah. So I'm going to call it 0.14, round it off. E to the -2, 0.14. And finally, e to the -3. So again, second function, ln, but on top of that is e. So I know I'm doing e. Okay, and this time I want -3. So negative is right here, and 3. E to the -3. 0.0497, blah, blah, blah. I call it 0.05. So there we go. So make sure you know how to figure it out on your own calculator. If you're not sure, ask somebody else or ask me later or during office hours how to figure all this stuff on your calculator. Okay, and now I graph it. Okay, and once again, this is typical of log functions. None of the x's are negative. Okay, so I don't devote that much space to it, although I guess I did. Okay, what's my biggest x? It looks like it's 20. So 5, 10, 15, 20. And for y, I just go from -3 to +3. Okay. So 1, 0, 2.71, less than 5. 7.4, 2. 7.4 is a little bit less than 10, and there's 2. And then 23, 20, 1, 2, 3. And then plot these guys. These numbers are very small, right? 0.37 and 0.14 and 0.05. They're really scrunched up against the y-axis, -1, -2. So I just make it go like so. Okay, and it's kind of the opposite action as over here. For the exponential functions, it looks like we're getting real close to the x-axis. For the log functions, it looks like you get really, really close to the y-axis. All right, so that's the graph of the natural log function, y equals ln x. Okay, and by the way, on an exam or quiz, you should show me this, okay? I happen to have a graphing calculator. Some of you have graphing calculators. If you do that, you can just type y equals ln x and it graphs it for you. But I want you to be able to show me this table to come up with this graph, because I'm not requiring that. So that wouldn't be fair to the students who don't have a graphing calculator, but you can all do this. Now, I don't mind you use your graphing calculator as a double check. If you know how to do that, you just push some buttons, it gives you this graph, but you can't rely solely on that. I want you to be able to come up with a table for me, like so, okay? Okay, so now I've done 1, 2, 3, and 4. So moving right along with some of the other problems. Okay, so I'm going to make this disappear. I'm going to jump to this problem here. And that looks like problem number 13. 13, log base 7 of x equals 3.1. Log base 7 of x equals 3.1. So again, write it without the log. To write it without the log, you start with the base, which is 7. You go across the equal sign for the exponent, 3.1, and you come back. So the answer is 7 raised to the 3.1. So 7 to the 3.1. Okay, now, on my calculator, to get an exponent, you use this button. Okay, so for exponent, okay, I've seen this. I've also seen a button that looks like y to the x, or maybe x to the y. Okay, sometimes you see something that looks like this, x, and then they put a little box here indicating it's an exponent. So just check your calculator. So exponent can be that, or that, or that, just experiment. So I want 7 raised to the 3.1. So on my calculator, I hit 7, and then I hit this button for the exponent. So this is for an exponent, and then 3.1. And by the way, that's the standard how you would type it, like on a keyboard. So how do you get an exponent? Normally, we would just type that. Okay, so my calculator looks like this, 7 exponent 3.1. I'll hit enter. I get 416.681. So you see here, 416.681. Okay. 14, all they want you to do is write this as a logarithm. So they're not asking you to solve, write it as a log. Okay, so we had a little bit of practice unscrambling a log, starting off with a log. Okay, what happens if it's like this? How do you make it into a log? So make this into a log. Okay, so how do I make this into a log? Well, the first thing you should do is write log. Okay, so log. Okay, then I would normally say, which of these elements is the base? What's considered the base? The base is 3, right? So the base always gets sunken down next to the g, like that. Okay, so again, it starts off with an exponential equation. Write it as a log. So how do I write it as a log? First, you just write log, which means log. I always say start with the base. So whether you're doing with an exponential or logarithm, you know, unscrambling, start off with the base. The base is 3. Okay, and now there's only 2 things left, the 2x and the 27. So which goes where? Okay, from my earlier discussion, the exponent always goes by itself. So that means the 2x is on the other side of the equal sign, and then you come back in for the result. Okay, so it should look like this. Log base 3 of 27 is equal to 2x. So that's how you would read it. Log base 3 of 27 equals 2x. And you can double check if I try to unscramble it, write it without the log, you would take the base, then the rule is you go across the equal sign. The equal sign can be on the right side or it can be the left side, but you go across the equal sign for the exponent, 3 to the x, and you come back in for the answer, which is 27, that you see right here. Okay. All right, I have 15 next, but I was going to hold off on that until I do some calculator problems. Okay, so I'll come back to 15 later, but there are some problems in the text that are just having you get used to your calculator. So that's 5, 6, 7, and 8. So 5, 6, 7, and 8, there's really no work. It's just how do you do it in a calculator? Okay, so 9 says e to the 4th power. I don't know if you can read that. E to the 4th, just punch it in a calculator to 3 decimal places. Okay, so if you can't read it, it says e to the 4th. So on my calculator, to get e again, on almost every calculator, it's above the ln. So you have to do second function ln. And again, on my calculator, it shows up as e. And they want the exponent to be 4. So I'll hit 4, e to the 4th power. 54.598 is the answer, looks like. Okay, at least get the answer down. Get the answer down now and experiment with your calculator later if you're not sure. And I'll also mention, on some calculators, you have to go backwards. See, I've noticed, so instead of hitting e to the 4th, I've seen some calculators where you have to hit the 4 first. You hit the 4 and then second function e to the x. So just experiment with your calculator later meaning after class. Okay, while we're at it, I noticed ln4, okay? ln4, you almost do the same buttons, except you don't have to hit the second function. So for e to the 4th, on my calculator, I hit second ln, which really means e to the x, and then 4. For ln4, you literally just hit the ln. So I hit ln, and see it says ln there, and 4. So ln4, 1.3862, so rounded to 3 decimal places, 1.386. Okay, and I want to mention something else about some calculators. Some of you have a calculator, once you hit ln, it automatically gives you a left paren. Okay. Mine doesn't. Okay. But some calculators, once you hit ln or e, it automatically gives you a left paren. So you folks, you have to close it with a right paren. So it's going to look like that. That's all. So just experiment. If you had an ln and it's a left paren, then close it with a right paren. And of course, you get the same answer. So that requires experimentation. So after class, maybe experiment that you can get these numbers. So at least get the numbers down. Get the answer down, 1.386. And then later on, see if you can experiment with your calculator to get what we want. Yeah, I'm not a calculator expert, and there's so many different calculators out there, but I can usually try to figure out how most of them go. Okay. All right, this one, 10, 3 to the negative 2.1. It says 3 raised to the negative 2.1. Okay, so I hit 3, exponent. So my calculator, the exponent is this button. Exponent. Again, it might be y to the x or x to the y, or maybe it gives you an exponent thing up there, right, floating up there. I'll show you all those possibilities. And the exponent they want, if you can't see it, it's negative 2.1. So negative, again, for me, the negative is here. Some of you, if you don't see this, it might say plus or minus, like I said. If your graphing calculator or scientific calculator has something that looks like plus or minus, that's how you would get it. And 2.1. Okay. And some of you might have to hit it backwards. In other words, you might have to hit the negative 2.1 first, and then 3 to that. And you might have to hit 2.1 minus. So just experiment. Okay, so I've got 3 to the negative 2.1, 0.0995. So 0.0995 rounded off would actually be 0.100, right? Because that 5 means you round up. So the answer is 0.100 for this one, please. 0.100. 0.0995, barely visible. Okay, log 21. Okay, log is this button. It's not the same as ln. Okay, for ln, the base is e. For log, the base is 10. So if you see log, there's an understood 10 here. And by the way, you can't really forget it because right above the log, it says 10 to the x. But this is a pretty good angle right here. See, above the log is 10 to the x. Above the ln is e to the x. So you can't really forget what the base is, because if you forget the base, just look up here. So when you see ln, you say to yourself, oh, what's the base? It's e. What's e? It's like 2.718. And for log, see, what's the base? It's 10. All right, so they want me to do log 21, so I'll just hit log 21. Okay. And again, if your calculator gives you the left paren, close it with the right paren. Anyway, this one looks like 1.322, rounded to 3 decimal places, log 21. Again, some of you, when you hit log, it automatically gives you something like that. So if your calculator goes like that, then after you hit 21, close it with the right parenthesis like that. And of course, you get the same answer as you're supposed to.
Professor, can I interrupt?
Yes.
So when you enter all this stuff, the log and then the parenthesis, or I mean the number, and then what do you hit in the calculator to get the answer?
Then I hit enter or equals way down here.
Oh, equal.
Equals.
Okay.
Some calculators it's equal. It's usually the button way down here. Some calculators it says equal or enter.
Okay. Thank
Right.
you.
So yeah, sorry, I should have showed you that maybe, but log 21 and then always enter. Okay. Well, it's almost like any calculator. If you just do something simple like, 3 times 4. Okay. Well, where's the 3 times 4? Well, you have to hit the enter, right? Or equals. And then there's the 12 or whatnot. Okay, so the last one, log 21, was 1.322. Okay, if you don't have time to experiment on your calculator now, just write down the answer and experiment with your calculator later. And some of you have to hit it backwards, like you might have to hit 21 log or 21 ln, right? If you don't have a sign that looks like this, it might be plus or minus. I've seen that on many calculators, right? So just experiment. If you're not sure, send me an email, and I can try to help find it for you. Okay, so we've done a lot of problems. Okay, so let's go back and do some more. I think I've almost literally done all of these. Okay, so let's get back to more. Okay, how about 15, please? Solve 3 plus 6e to the negative 2x equals 7. Okay, so first I need to isolate the e stuff. So subtract 3, right? So what happens when you subtract 3? The right-hand side becomes 4, right? I'm going to move the book out of the way temporarily. Okay, divide both sides by 6. So I have e to the negative 2x equals 4 over 6, which is 2/3. Okay, so now it looks like this. E to the negative 2x equals 2/3. And now the trick. I want to get rid of that e. Okay. Hopefully you see something like that in your intermediate algebra. To get rid of the e, you take the natural log of both sides. You ln both sides like this. Because whenever you have an ln and an e next to each other, like that, they just cancel out. Okay, so one more time. Back here, subtract 3, right? Divide by 6. So you have e to the negative 2x equals 2/3. Now take the natural log of both sides. ln, ln. ln stands for natural log. Whenever you do that, these cancel out. So you have negative 2x equals ln of 2/3. And divide both sides by negative 2. So we divide by negative 2, and now it looks like this. So x is equal to ln parentheses 2/3. And by the way, in this case, everybody needs to put the parentheses. Even if your calculator doesn't automatically give you the parentheses, you have to put it. So x is natural log, parentheses 2/3 divided by negative 2. Okay, so evidently the last time I did it, it got 0.203. Let me try to get that. So ln parentheses, so parentheses 2 divided by 3, ln of 2/3, and I'm supposed to divide that by what? Divided by negative 2, so divided by negative 2. So I think I typed it incorrectly. So ln parentheses 2/3, close parentheses, divided by negative 2. There it is, 0.2027, which I'm going to round off to 0.203. Try to make the screen darker, but I don't know if I can. Try to make it as dark as possible. But anyway, it says 0.2027, so 0.203. Okay, 16. 8 minus log base 3 of 5x minus 13 is equal to 5. Okay, 8 minus log base 3, 5x minus 13 equals 5. So first thing I want to do is isolate the log. So I get rid of the 8. So how do I get rid of the 8? Subtract 8 on both sides. Minus 8 minus 8. 5 minus 8 is negative 3. So I have negative log blah, 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 blah equals negative 3. Negative log base 3 of 5x minus 13 equals negative 3. The left-hand side has a negative. The right-hand side has a negative. There's a very easy remedy. Multiply both sides by negative 1. So in red, negative 1 times that, negative 1 times that, cancels this, and now everything's positive. So now I have log base 3 of 5x minus 13 equals 3. So it looks like this. Okay, so I wanted to isolate the log stuff. Okay. And now I do my unscrambling route. I unscramble it, write it without the log, start with a base, which is 3. You always go on the other side of the equal sign for the exponent. So I swing way over here, the 3 for the exponent, and I come in for the answer. So it's 3 raised to the 3rd is equal to this stuff. So 3 cubed is equal to 5x minus 13. And now I have a fairly easy equation. Okay, base is 3, go across the equal sign for the exponent, which is also 3, come back in for the result. So I have 3 cubed, which is 27. And now I have a fairly easy equation that we all know how to solve, right? So let's see, add 13 to both sides. Add 13, 27 plus 13 is 40. 40 equals 5x. Divide by 5, x equals 8. Okay.
Professor,
Yes.
can you please go back up top to the point where you got the -1 on the left side, right side?
Right here? Okay.
Yes, please.
Right over here, I subtracted 8 on both sides. So it looks like this. Negative, that negative is the same as that negative. So negative log blah, blah, blah equals -3. So there's a negative on both sides. So if I just multiply both sides by -1, they're positive. Okay? In fact, if you want a shortcut, those two negatives, the negative right there, the negative right there, the next step, you could just drop it. Just drop the negative. Okay, so if I multiply both sides by -1, -1 times that becomes positive log blah, blah, blah. And -3 times -1 is +3. Okay, so a shortcut that I'll allow, if you ever have an equation like this, where the left side is negative whatever, and the right side has negative whatever, the next step, just drop the minus. Drop that minus, make them positive. Okay, is that what you meant?
Okay, so the goal is to end up at a positive on both sides.
Correct. Okay, why have negatives when we don't have to make positive? You can't always, have positives on both sides, but I certainly don't want negatives on both of them. I'd rather have positives on both of them. And the way to do that is to do this trick, multiply by -1.
Okay, thank you.
All right, you're welcome. Okay, there's just a couple more things, and then I'll stop and give you the quiz. I'm going to talk real quickly only about 18 and 20. Okay, 18 says e to the ln x to the 4th, and 20 says ln e to the x squared. Okay, so let me show you that because it's kind of hard to see in the book, but they're actually very, very easy. Of course, they're only easy if you know what to do. So let me see if I can squeeze that in here. So 18, please. Looks like that. Okay. So it turns out anytime you have an E and an ln next to each other, they just cancel each other out. An E and an ln cancel out. So all you have is x to the 4th. So there's really no work. So you know how I say every time you have a quiz or test or homework, show all your work. This one there is no work. You just cancel the E and the ln. And you have x to the 4th. And by the way, that's sort of the trick I did way back over here. Okay. Anytime you have an ln and an E next to each other, or an E and an ln, they cancel each other out. So automatically 18 is just x to the 4th. Okay. So E and ln cancel out. E and ln cancel if you have them back to back.
Professor, why do they cancel each other out?
Why do they cancel out? It's more in depth than we care, but it's sort of the definition. They're defined that way. E is the function that knocks out the ln, and ln is a function that knocks out the E, so to speak. Okay, it's going into more detail than I care to talk about. But let's say on a calculator, if you ever did E and ln right next to where you're back to where you started from. Okay, so for now, just take it that they cancel each other out, and it could also even be thought of as a definition. The definition of E and ln, whether they cancel each other out. Okay, but just for fun, if I hit E raised to the ln of 2, then I get back 2, I notice. So E and ln of 2, I got 2. And you can reverse it. You can do ln E 2 like that, and I should also get 2. Okay, so they're defined that way. And by the same token, question 20, it says ln of E to the x squared. I'll write it for you. So it can be written like this. So you can have E to the ln, they cancel out. Or it can be written like this, ln E to the x squared. Once again, they cancel out. So simply the answer is x squared. And that's it.
So either it's a power or they multiply each other, right?
It's not really a multiplication, it's an application of a function, really, okay? But if you don't understand all that terminology, that's okay. Just remember, if you have an ln and an e next to each other like that, they cancel out. Or it can look like this. I know it might look a little bit weird, but e almost always wants an exponent, so that's why it's raised up. But e and an ln raised up like that cancel out. If you hear some whirring noise, sorry, that's coming from my computer. The computer, I think, is dying. I'm getting a new computer tomorrow, so if I can just hang on past today, then I'll get a new computer from work. And I told him my computer is dying, and I hope it lasts the rest of today. But that's that. Okay. All right. So, folks, I'm going to stop there. I've done almost all of chapter 5. So Tuesday, I'll knock off the rest of these. And again, when you come into class on Tuesday, please be ready for questions and answers about any section. Okay. And then next Thursday is a test. Okay. So right now, we're going to switch to quiz mode. So I'm going to make this disappear. Okay, so here's the quiz. Now, you may either write it or take a picture on your cell phone. So let me give you maybe a minute or 30 seconds about this, and that'll break you off into your break-off groups. Okay, so number 1, graph y equals absolute value of x after making a table of values from -2 to 2. Okay, so make a table of values from -2 to 2. You should know what absolute value does. If you're not sure, ask your teammates in your breakout group. And 2, solve the equation x squared minus 3x equals 10. I'll give you a hint. This is a square, so it's a quadratic equation, right? So how do you solve a quadratic equation? And I'll give you a hint. You shouldn't leave it like that. You got to do something with the 10, right? So can you remember what happens on the right-hand side? And then go from there. Right. Okay, so I'll give you a little bit longer, and we're still recording, so if you missed this completely, it is going to be on the video later. But take a picture on your cell phone or write it all down now. Okay, but I'm going to switch off in just a moment. Okay, so again, graph y equals absolute value of x. So what does absolute value do? Make a table of values from -2 to 2, and then solve x squared minus 3x equals 10. Okay, so you can work on it for a while because it takes me a few seconds to, stop the recording and switch to that and make the breakout rooms. Okay, so I think everybody's had enough time. So I'm going to make this disappear. I will stop the share.